So to determine the polarity of a molecule, you would look at the Lewis structure of it and based off of the atoms in the molecule itself and where they are on the periodic table, you can easily determine if it is polar or nonpolar. So for SO3, you would draw it out as such, and because it requires a double bond on one of the O's, it means that it'll be trigonal planar in geometry, which means that because all three of the oxygen atoms would be pulling in the same direction or pushing each other equally, all of the molecular dipoles, or no, sorry, the bond dipoles would cancel out, and therefore making the entire molecule nonpolar. For OF2 is a little different in that because the oxygen has two unshared pairs of electrons, those would push the two fluorine atoms to make it a bent shape molecule, which means that even though the bond dipoles are pointing towards the fluorine and would be down here per se, the unpaired electrons would outweigh any electronegativity going towards the fluorine atom, making the atom have a molecular dipole towards the unshared pair of electrons, making the entire molecule polar. For BeCl2, because it has two double bonds, it is linear in geometry, and being that it's linear, it means that the two bond dipoles going towards the chlorines would cancel each other out, therefore making the entire molecule nonpolar. For CCl4, because it's tetrahedral in that all four of the outside atoms are the same, all of the bond dipoles are equally pulling in four different directions, making the entire molecule nonpolar. They all cancel each other out. As for O3, O3 is polar because of the fact that these two unshared electrons would push this oxygen and this oxygen to make the geometry bent, and therefore, because it's bent and the fact that there are no bond dipoles because it's all oxygen atoms, it means that the molecule would be polar because of the unshared electrons on top of the central oxygen, making it polar towards the top of the atom.